On to the next question. There are 180 students at a college following a general course in computing. Students on this course can choose to take up to 3 extra options. So various different combinations here and the counts for each of them, and we're asked to draw a Venn diagram to represent this information. Okay, so reading through, there are 3 extra options, so that lets me know that my Venn diagram should have 3 overlapping circles, so those are for the 3 different sets. So I'll start with an empty Venn diagram and go through one statement at a time trying to fill in the Venn diagram. The strategy when filling in the Venn diagram is to start with the overlaps, and we'll start with this overlap of 3 different sets. Firstly, let me label them. So the 3 things are system support, label with an S, developing software with a D, and networking, we'll label with an N. Let's go ahead and fill in these values. As I read through, I realize that the overlaps are at the bottom, so I will start from the bottom. 4 take all 3 extra options. So 4 of these students are taking all 3, so a 4 in that overlap there. 40 students take system support and networking. System support and networking should be represented by this area here, and I want the total in that area to be 40. I already have a 4, which means I need another 36. So in this small section over here, we want 36. 28 take networking and developing software. Networking and developing software is this region over here, and I want that to be 28. I already have 4. To get my 28, I'm going to need 24. 35 take developing software and system support. The overlap of those 2, system support and developing software, is here, and I need that to be represented by 35. I already have a 4, so that's going to give me 31. Okay, so I've represented the overlaps. So these 4 statements have been dealt with. I've represented each of these, just a few more to go. Networking, in total, networking, all of this, I should have 81. What's the count at the moment? 64, I need that to total 81. So that's 17. 70 take developing software. This area needs to add up to 70. That gives me 11. And finally, I need 112 people to be represented in this set of system support. So adding up what I have already and subtracting it from 112 is going to leave me with 41 students studying system support. Okay, let's not just assume that the question is done. One of the earliest things we were told is that there were 180 students. At the moment, these values do not add up to 180 because some students are not taking any of the extra 3 options. So 180 minus all of the values that we have at the moment is going to leave us with 16. 16 needs to be on the outside. There's a mark for that value of 16. There's a mark for the 3 overlapping circles, and there's a mark for making sure it's all enclosed within a box. Okay, so be careful to get all of those there. Okay, next we're told that a student is chosen from this course at random. Find the probability that this student takes none of the 3 extra options. So it's a good thing we calculated that in the earlier question. So it's none of the 3 earlier options that we're looking to calculate. The probability the student takes none, which will be our 16 over the total 180. That will definitely simplify, or you can write it as a decimal. Fraction maintains accuracy, 4 over 45, or 0.0889. Okay, still referencing our Venn diagram, what's the probability that a student studies networking only? So they will only do 1 extra subject, and that will be networking. Quickly identifying that must be the 17 from the Venn diagram. Probability of networking only equals 17 out of 180. Not as easy to simplify. In fact, it doesn't simplify. 17 is a prime number. Leaves us with 0.0944. Okay, so students who take system support and networking are eligible to become technicians. Given that the randomly chosen student is eligible to become a technician, find the probability that this student takes all 3 extra options. All right, clues in the question. So system support and networking means they can become technicians. So every time we read technician from now on, we know we're talking about people who study system support and networking. Given that the randomly chosen student is eligible to become a technician, find the probability that this student takes all 3 extra options. So this was a given question, and we're finding the probability that they take all 3 extra options. Okay, so let's look back to our given formula. Probability of A given B. It's the intersection of A and B divided by the probability of B. Okay, so in this case, let's make sure we read that given statement correctly. We're looking for the probability that someone takes all three, so all three extra options, given that they're eligible to be a technician. Okay, so all three is our event A, and being a technician is our event B. So we're looking for the probability that they do all three and they're a technician over the probability they're a technician. Okay, so let's bring that Venn diagram back in for reference. What is the probability that a student studies all three and they're going to be a technician? Well, all three is here. Do these people satisfy the condition of being a technician, which means that you need to have studied system support and networking? Well, yes, all four of those do study system support and networking. So that probability, so the amount of people we're talking about is 4. So that probability is 4 out of 180. What's the probability that they qualify for being a technician? So that's going to be 40 out of 180. All right, let's remember we didn't really need those denominators because they would cancel out at this stage anyway. Multiply the top and the bottom by 180, and we just get the numerators in here. 4 over 40, nice and straightforward. It's 1 over 10, or 0.1. So given that a randomly chosen student is eligible to become a technician, the probability that they take all three extra options is 0.1. And that should be worth all your marks.